Okay,
That's so, that's not even, that's so far away.
so this,
Be a bumblebee.
this construct works for the little stopper on the string. It also works for, let's say you wanted to,
Roller coaster.
Okay.
Sucking down side to side.
let's say you wanted to go through a loop, okay? So you're gonna put a block up here, okay? And it's gonna slide through the loop here. Now, this loop isn't exactly circular, because I didn't draw it circular, but we can assume it's circular, at least in that section there, right?
Sure.
Does that make sense? So, if it's going nice and fast, what are the forces at that moment?
You got MG.
And what else?
Yes.
It's the normal, because it's a perpendicular surface force. Does that make sense?
Are we applying V minimum to this?
That's right, and so what we have here is we have the same construct that says the net force was gonna be the addition of these two.
Or the subtraction.
Because it's a net force and it's in circular motion, it's mv squared over r. Those are both the net force.
And as velocity decreases, Fm just disappears. Right?
That's right. The slower you go, the less normal force, which means the less it pushes on you, right? And at your V minimum, what happens?
Fm is zero.
FM drops to 0,
That's right.
and then you go
Mike,
to the forever sleep.
Does that make sense? Now, you can still make this at the minimum speed. You're just gonna like come off the track the tiniest bit and then make it
I'd
back.
rather not.
Okay. Let's talk about free fall for a quick second.
I used to not, but then I developed this like lack of fear for death, so now I don't really care.
That's a really good point.
Mr. Powder, do you like roller coasters?
You know, I liked it when I was a little kid. I love the conceptual framework of roller coasters, but I will say, I think the Top Thrill Dragster is the most amazing thing ever.
Oh my god, I love it.
I think it's so overrated.
You get such a good view of the park, but you
Yeah,
have to
but
wait in line for like 2
I think
hours.
he's talking
For
more
10
about the
seconds.
physics behind it, guys.
You know what,
Oh,
whatever.
sorry.
I think the physics of it are so amazing to just see it, the acceleration. It goes from 0 to like 120 miles an hour in like 4 seconds.
Do you know the
Yeah, stop,
actual
stop.
top fuel dragsters, like the actual drag cars go from 0 to 60 in 0.2 seconds?
All right, if you drop a baseball,
They should have you do that.
if you drop a baseball and you drop a bowling ball, which has a larger acceleration as it's falling to the ground? Do they have the same acceleration?
Yes.
But how is that possible?
What's this section? What should I call this section?
This is just an ancillary piece of information. Yeah.
So in a perfect vacuum, there's no air resistance, and since we know the acceleration of the Earth is constant for any object, they should hit the ground.
But why is the acceleration the same for both? You see my question?
I almost said it.
So
I almost said
our
it.
naive concept says that, well, the gravity is the same for both.
Yeah.
But that's not true. Because if you look at the
Yes.
forces on this, this is a big mg. This is a little mg. Which one weighs more? The bowling ball or the golf ball? Or the bowling ball or the baseball?
Oh.
It weighs more. The Earth pulls it down more.
But G is the same.
But why? How is that? Why is it the same, man? Yeah.
Because
Oh,
the
you
mass of the
explained
Earth
this.
doesn't change.
Well, yeah, the mass of the Earth, but that's down here. The Earth is way down
Yeah.
here. Right?
Are we in space at this point?
No.
I was just dropping from like 10 feet.
You see my question?
Yeah, and I.
How is it possible that these two objects have the same acceleration? Yeah.
I think the gravitational field strength stays the same.
The gravitational field strength is the G, it's the little
Yeah.
G for both of these.
Isn't it the same construct as like we were having earlier with what were we talking, impulse today, how it, what was the concept we were talking about today? I literally had it and now I've lost it. Ignore me, I'll figure it out.
Well, let's do it this way. What does Newton's second law say about objects accelerating?
Force divided by mass.
So if I'm going to find the acceleration of an object, I need to know the net unbalanced force and the mass, true?
Oh, it's because there's gonna be a greater F net divided by a greater M, which is gonna get you the same acceleration.
Cause it's, yeah,
But the F net's gonna be smaller with a smaller mass, which gives you the same acceleration.
I remember that.
So the thing you need to know is that the Earth pulls more on more massive objects.
Like that, no? But it takes,
But because it's more massive, it resists change in its motion more. So you need more force to get it to go.
Earth
That's so.
pulls more.
So this one over here would have a much bigger net force and a much bigger mass. This one over here has a smaller net force and a smaller mass, and therefore they have the same acceleration.
So it's Earth pulls more on massive objects but needs more force to go.
Yeah.
Seems. Look at us learn anything.
Now, here's the cool part. We have two G's on the wall, okay? We have two baby G's on the wall. The top one is the gravitational field strength, 10 newtons per kilogram. The bottom one is the free fall acceleration. But they use baby G for both in a concerted effort to confuse you, okay? But mathematically, let's see what happens here. If I go to actually calculate the acceleration of either one of these, what is the net unbalanced force on the baseball?
MG.
It's just mg, right?
Oh, I get it.
yeah.
Over little m's cancel, and that's gonna be big MG over big M.
Yeah.
It's canceled, so it's just equal to G.
So for the baseball, it's little mg,
Feel really intelligent
okay? But here's the thing. This g here is the gravitational field strength, but in a little bit of sleight of hand, they're like, oh, well, that means the acceleration must have the same value.
Yeah.
They
So-
don't show you how, but it makes sense, but like, not really.
Yeah, so the g's are the same thing, but contextually they're different because, you know, if I put an object on the table here, there's gravitational field strength there,
Which is 10 newtons per kilogram.
but it's not accelerating.
But then if you move the table out of it, and then there is no force normal anymore, then it would be
Yeah.
accelerating every time. But when it's accelerating, is there still 10 newtons per kilogram
So
and 10 meters per second?
the gravitational field strength exists regardless of any masses.
So there's both at that point.
Yeah, like I know there's gravitational field strength over there, because if I go over there with an object, I'm gonna feel the force.
So
The
when,
field is there regardless of anything else.
so when an object's dropping, it actually has 2 G's on it.
Yeah. That cool? Guys feel okay about that? All right. That was
Thanks for that.
just a little quick aside that I thought was important.
It's
What was that?
lead.
You ran out of pencil then?
No, he just stole Claire's pencil lead out of her
She
pencil.
insulted me.
It's not the first time today.
Literally isn't the first time.
What did I
I've
say?
started blocking you guys out of the other side of the room.
Oh.
It's a good idea.
Yeah.
That's very
That's a
distracting.
good idea.
I'm just waiting for a chair to go rolling at your head at one point.
It'll happen for the year, I feel like it might.
Please do.
Yeah, but we'll be sitting next to each other, so I'll just like.
Can we just make sure the camera's recording when you
Claire.
No way, man.
Now you gotta be conspicuous while your chair's going.
I'm super chill.
Never talk.
All right. So we've seen the different frameworks for this, right? We saw the kinematics, we saw projectile, we saw circular motion, we added the forces, right? And then we saw how all that comes together, which I think is really cool, all right? And then eventually we gotta add some energy in. But I don't wanna start it now because it's a little,
I think that's a good way to end today's
getting
article. I think
finished.
I think we're good where we're
I
at.
think I've realized that I forgot a lot of things.
But I think these actually really help.
This was so super helpful.
well, it just brings you back.
Yeah,
Like, oh, that's right, or, oh, that's what that was? And both of those are really good.
yeah.